Welcome to the Georgia Highlands College Chemistry Podcast. In today's podcast, we will be discussing molarity. Molarity is a measure of the concentration of a solution. We will find this very helpful with dealing with solutions in our calculations. Molarity is defined as the number of moles of solute divided by liters of solution. When we rearrange this equation, this is another way to come up with moles. Liters times molarity gives us moles. In our first example, we were asked to calculate the number of moles of sulfuric acid in 500 milliliters of 0.234 molar sulfuric acid solution. So we have liters or milliliters of solution. We need to convert this to liters using the definition 1 liter is equal to 1,000 milliliters. And then multiply this liter times molarity, 0.324 moles of sulfuric acid per liter of solution. So in this solution we would have 0.162 moles of sulfuric acid. In another example, calculate the molarity of a solution that contains 12.5 grams of sulfuric acid in 1.75 liters of solution. So all we need to do here, since we have liters of solution, we just need to convert 12.5 grams of sulfuric acid to moles of sulfuric acid by dividing by the molecular mass of sulfuric acid, 98.0 grams per mole. So in this case, the molarity of the solution would be 0.0852 molar. Another typical question is determine the mass of calcium nitrate required to prepare 3.5 liters of 0.8 molar calcium nitrate solution. So again, liters times molarity gives us moles. So 3.5 liters times 0.8 moles of calcium nitrate per liter. This gives us moles of calcium nitrate, and then we convert to mass by multiplying by the molecular mass of calcium nitrate, 164 grams of calcium nitrate per mole of calcium nitrate. This gives us 459 grams of calcium nitrate. So if we took 459 grams of calcium nitrate and dissolved it in a total volume of 3.5 liters, the molarity of the resulting solution would be 0.8 molar. In another example, in this case we're doing a chemical reaction, and it says what volume of 0.5 molar barium chloride is required to completely react with 4.32 grams of sodium sulfate. In our balanced equation, we have 1 mole of sodium sulfate reacts with 1 mole of barium chloride to form 1 mole of barium sulfate and 2 moles of sodium chloride. So since we have grams of sodium sulfate, we need to convert to moles of sodium sulfate by dividing by the molecular mass of sodium sulfate, 142 grams per mole. At this point we have moles of sodium sulfate, and to convert to moles of barium chloride, we just multiply by the stoichiometric ratio. 1 mole of barium chloride is equal to 1 mole of sodium sulfate. Now that we have moles of barium chloride, divide this by the molarity of the barium chloride solution, 0.5 moles per liter, and we end up with liters. When we punch this through our calculator, we get 0.0608 liters. In this example, we are asked what volume of 0.2 molar sodium nitrate will react with 50 milliliters of 0.2 molar aluminum nitrate. 1 mole of aluminum nitrate reacts with 3 moles of sodium hydroxide to produce 1 mole of aluminum hydroxide and 3 moles of sodium nitrate. So we convert 50 milliliters of aluminum nitrate to liters of aluminum nitrate by multiplying by the definition 1 liter is equal to 1,000 milliliters. Then we can convert to moles of aluminum nitrate by multiplying by the molarity, 0.2 moles of aluminum nitrate solution per liter of aluminum nitrate solution. Now we have moles of aluminum nitrate. To To convert to moles of sodium hydroxide, we multiply by the stoichiometric coefficient. 3 moles of sodium hydroxide per 1 mole of aluminum nitrate. And then to convert to liters, we divide by the molarity of the sodium hydroxide. 0.2 moles of sodium hydroxide per liter of sodium hydroxide. And this will give us a volume of solution required to react of 0.150 liters. In another example, a very typical one of lab situations, so it's important to us in this course, what is the molarity of potassium hydroxide solution if 38.7 milliliters of the potassium hydroxide solution is required to react with 43.2 milliliters of 0.223 molar hydrochloric acid. When we see our balanced equation, we can see that 1 mole of potassium hydroxide reacts with 1 mole of hydrochloric acid to produce 1 mole of potassium chloride and 1 mole of water. So again, we start off converting 43.2 milliliters of our solution to liters. About 1 liter is equal to 1,000 milliliters. And then we can determine moles of hydrochloric acid solution by multiplying by the molarity, 0.223 molar. So this gives us number of moles of hydrochloric acid reacted of 0.00963 moles. To convert this to moles of potassium hydroxide, we use our stoichiometric coefficient. 1 mole of potassium hydroxide is equal to 1 mole of hydrochloric acid. So at this point, we've determined that in this solution we have 0.00963 moles of potassium hydroxide. The volume of the potassium hydroxide solution was 38.7 milliliters. 38.7 milliliters is equal to 0.0387 liters. So using our definition of molarity, moles of potassium hydroxide divided by volume of potassium hydroxide solution would give us a molarity of potassium hydroxide equal to 0.249 molar. Molarity is very commonly used in the lab with dealing with liquid solutions. So this is an important concept for us to try to grasp in this course. I hope this podcast has helped you understand a little bit about using molarity in various types of calculations. Thank you for listening to this Georgia Highlands College Chemistry podcast. I look forward to seeing you at our next episode.